Last video we finished tutorial 4, lesson 2, which was all about basically using draw.io and drawing things, and now we're moving on to lesson 3. So for this we're going to talk about how to connect your state machine to the outside world, and because we've finished most of the drawing parts of tutorial series for tutorial 4, we're going to jump back into join tutorial 3's lesson 3 here. So if I click on this link here, so even though that tutorial 3 is focuses on plant UML, at this point we don't need to worry about the diagrams anymore. Like, you can just look at the images, you don't have to worry about the plant UML syntax if you're not interested. So with that out of the way, let's keep going. So I should note too that this is optional. It is an architectural lesson, and it is really useful if you have multiple instances of the same state machine. But if you only have a single instance of a state machine, you can continue using the global functions approach that we have used in previous lessons. And yeah, you don't need this at all. Feel free to skip over this, continue on lesson 4 in tutorial 3 still. So each language listed below has various technical options for connecting your state machine to the outside world. You can use global variables and functions. You can use input and output variables specific to your state machine. You can use composition and interfaces. You can use inheritance, including files, or partial classes. This tutorial is still JavaScript specific. The next lesson will be programming language specific and break out from JavaScript to each individual language listed here. But for now, we're going to be kind of restricted to what JavaScript is able to support. So in terms of global functions and global variables, this is essentially what we've been doing in the tutorial already, and this actually works really well if you have a single state machine instance, so a single instance of one particular state machine. You can have multiple different designs, like maybe a server one and a client one, all in the same project, but if we only have a single instance of each of those, globals will still work fine. However, if we wanted to have a whole bunch of light controls or light state machines all running in the same project, it would be more difficult to use globals, and at that point it makes more sense to use some of the other approaches. Your state machine doesn't actually need to call any functions or access globals to be useful. It can simply use input and output variables. So you can see the variable-based folder for details. At a high level, just graphically what we just said there, you can declare input variables and output variables. When your state machine runs, it reads its inputs, it processes them, and then it writes to its outputs. Let's go take a quick peek in here. So in our light state machine, like I said, we declared some inputs, we declared some outputs, and as we talked about in previous examples, the syntax here is specific to your programming language. This is for JavaScript. You'd use different syntax for other languages. Now, you can actually use the state machine code like this. So we've got a bit of pseudocode here. So pseudocode that runs the state machine every loop. And the state machine here's instance is called SM, like that's the variable in the class that's using this. So we're saying state machine variables timer milliseconds, and we're just adding something to that to make the timer increase. Then we run the state machine here, dispatch an event to it, and then after that's done, we're going to use the outputs, the background color and the font color, to do some work. That's basically the gist of it. We can zoom out a little bit here. This is another way to visualize it. So we've got this light controller class here, which has an instance of our light state machine here. And when the update function is called from like the GUI, the light controller first sets the FSM's input. So it says, okay, update the timer milliseconds. Then it sends the do event to the state machine. The state machine reads its input values, processes them, writes to its outputs, and then the light controller uses those to, take the font color from the state machine, the background color, and connect that to something on the GUI. That's the gist of this one. So we'll pop out of here. That one's done. If you're using C99 or C++, we have a separate tutorial about using inc files. And what this basically boils down to is allowing you to include a state machine into the bottom of like a private or like an implementation file. So again, we have a light controller here, and maybe you want to keep a bunch of stuff private. And I know it's easier in C++, but in C it's hard to do private variables that need to be accessed by another file, like if this was light state machine.c, then you have to jump through a bunch of hoops to try to protect these, but also make them accessible outside. Possible, but work. Using this approach, we can basically tell Statesmith to generate a .inc file instead of a .c file, and then we can include it down here. And then it's kind of like you hand wrote your state machine inside of the light controller class, which many people would normally do if you weren't using something like Statesmith. And then all of the functions that the state machine needs can still be private here. You can have private variables, and it works well. And the reason why we generate a .inc file instead of a .c file is that it doesn't mess up any of your build rules or globbing for like compiling all the .c files. Composition and interface. So again, if we want to stop relying on globals, we can give our state machine a particular reference to an interface or context object that provides the functions and variables that the state machine needs. This example actually goes a little bit deep, so I'm going to just overview it here. There's a lot of different ways you can do this. The example in that link is just one possible way. But graphically, you can look at it like our state machine here the user has declared a context variable, and that context variable gets, and this can be named whatever you want. It could be interface, iFace, whatever. So I've named it here context, and context is wired up to point to some handwritten class, like an interface class here, or you could call it a context object. And then when the state machine is dispatching an event, when it's processing an event, it uses that context variable to access these helper methods called reset timer, is timer expired, turn on, turn off. You can also use inheritance if your programming language supports that. So in this case, you can tell your generated state machine to extend a base class. And inside of that base class, you can put protected members, variables, fields, and functions. JavaScript doesn't have a protected keyword in here, but other languages like Java and C# do. So if you want to, you can click into here, but this is the basic gist of it. It's not that complicated. If you're targeting C#, you can also use partial classes, and that's similar to the inheritance approach. That finishes our overview of Lesson 3. If you'd like a deep dive on one of those particular approaches, leave a comment below and I can try to make a video explaining with more detail. But for now, it's time to move on to Lesson 4, which is the programming language specific section. And again, we are in Tutorial 3. If you came from Tutorial 4, which was Draw.io, they basically have the same content now. So Tutorial 3 is where we're headed next.